We're going to talk now about the final protocol that is one that we're going to be discussing as part of the application layer of the TCP/IP model. I've decided to separate this out. I really should have done this in DHCP in their own video, but if you look at the last video, DHCP was included in that. But DNS, Domain Name System. I guess to simplify it down, this is the sort of system of servers across the internet that communicate together so that when you go to google.com, you don't have to remember an IP address for a web server out there on the internet for Google, right? You just know, you remember the URL, you remember the domain name, google.com. Okay, so that's in a nutshell what it comes down to. So if you want to break it down, you have as part of the DNS system, top level domains. This would be the .coms, the .nets, govs, orgs, everything else that's at the end of your domain, the whatever. Okay, and countries also have a two-letter country code. So the US would be obviously .us. Okay, so and then after that you have the second level domain. This is the part that says Google or Amazon or Facebook or Yahoo or whatever and then your top level domain. So your second level and top level domain are the minimum requirements for a domain name in the DNS system. Now the DNS system also has the ability to do subdomains so that you can categorize different web servers or different subdomains that are part of your overarching domain. And this would be if you have a so for instance, let me give you a for instance for this, office.microsoft.com. In fact, I think they own office.com nowadays, but back in the day, or in fact even today, still you can go to office.microsoft.com in order to get to their website that's all about Office products, so the Microsoft Office suite. Okay, so that would be a subdomain categorization. Or in the case of the book or this chapter, one that's commonly used is books.tomshow.com is your second level and top level domain. Books would be your subdomain. So that's where you would find information about the books written by our program director here at Yavapai College in the CNT department, Greg Tomshow. So books.tomshow.com. You've got a subdomain, a second level, and a top level domain. And then you have a host level. This would be for individual computers hosting network services. When you're actually looking at a domain in terms of like a Windows domain in particular, each computer is assigned a computer name. And in a Windows domain, you can actually use the host name in combination with the second level and top level domain to access different computers across your domain. So that's similar to subdomain, but it's a little bit less of a categorization methodology, and actually for specifying specific hosts. So we'll look at how the DNS system sort of works here as we go through, but that's the important aspects of a domain name. Okay. Let me put out there as well, when you have all of these three, one of these two, host level or subdomain level, and then these two put together, you have what's known as a fully qualified domain name, FQDN. Okay. All right. So when a server is installed, the administrator creates one or more domain names or zones. This is when you're talking about a domain name server, or a DNS server rather, domain name system server. When one is installed, your administrator will create one or more domain names or zones. So zones are how lookups occur within a domain. Okay. So typically zones will be categorized by subdomain if you have multiple, or just by the second level and top level domain name. Okay, so I'm going to kind of so your domain name is going to contain a list of IP addresses that point to root servers. Root servers are how I'd rather just, you know what, I'll just throw that out there. But there is a graphic in this PowerPoint that's really, really handy for demonstration purposes. It's going to help you to really understand what we're talking about. But just keep in mind that the root servers are sort of there's 13 of them, and these are the guys who keep all DNS information and propagate it throughout the internet. And essentially, they contain the top level domain addresses. So these are the guys. They're administered by ICANN and IANA. These are large conglomerates of companies that work together to keep the internet functioning within standards. So, DNS clients in OSs maintain a DNS cache called a resolver cache. This is if a computer on a network is consistently accessing a particular domain name, second level and top level domain name, it's going to keep a resolver cache of those domains so that it can quickly access that without having to go into the DNS system. That's why if you go to Google a lot, it may load slowly on the first time you go, but then after that, as you continue to go there a lot, it's going to continue to stay within that cache, that DNS cache that's locally stored. You can actually look this up on your computer. There's a variant of the NSLOOKUP command that lets you look up your local DNS resolver cache. So, and of course, this cache just stores names and IP address pairs and other data. Okay. So the client end is what's actually going to be producing resolvers. These are queries that search the DNS system for an IP address if it's doing what's known as a forward lookup, and it searches for a domain name if it's trying to do a reverse lookup. Generally, what's used is a forward lookup. That means I type in an IP address into a web browser. It checks the resolver cache stored locally. If it doesn't find it, then it begins to go to its DNS server. The DNS server that's local might not have that information stored, so it's going to go into the DNS system. We'll kind of break that down, and you'll see what that comes down to when we look at that particular slide. But each DNS client is going to send out a resolver when it's trying to find a domain name on the internet. Okay. When you are configuring IP address settings or even DHCP settings, you set up a DNS server. That would be your preferred DNS server. That's where it's going to check first. If that information is not found, or if that server is not found, it will check an alternate DNS server. Okay, or really, I think if the server is not found, it'll fail. But if the information isn't found on that first DNS server, then it'll check the alternate server. So I hope. Okay, so this is what DNS client settings look like when you set a DNS server on your on your network. This is what it's going to look like. So you'll set, this is if you're doing a static IP address and you're not using automatic IP address with DHCP, which we talked about already. It's going to use this preferred DNS server first. If it doesn't resolve the domain name there, then it'll try and resolve it here. Okay. So, okay. So this in Windows, the domain default domain append DNS lookup is called the primary DNS suffix. This is referring to how your computer is looked up in a Windows domain. So if you look here, we've got the netess.local is our domain, and this is the suffix that our computer is going to use to make a fully qualified domain name. So when it looks up net-01.netess.local, that is what it's actually using to resolve the IP address of this computer. So the computer that has these settings configured is using net-01.netess.local to resolve using DNS this computer's IP address. Okay. So, and in a non-domain environment, you just use the computer name. NetBIOS sort of uses something similar to this. It's not exactly a fully qualified domain name like this, but it uses sort of the workgroup name rather than a domain name. Okay, so the DNS server is composed of the following information. You have, first of all, DNS zones. This is your database of hostname and IP address pairs. Then you have a number of different record types. Resource records are going to vary wildly, but typically they contain data that points to some kind of server, some kind of host to resolve an IP address to a domain name. There's a number of different ways this happens, but I'm not going to delve into that. That's beyond the scope of this class. And then you have a cache. This is going to cache queries that are regularly happening, so your local DNS server will hold a cache. Root hints, if it doesn't have it in its cache, it's going to jump off to a root hint server. This is going to point it to the right direction. So we'll see that in the picture. I think the picture that I have demonstrates this in the best possible way. And then, of course, as a DNS server, you'd be running the DNS server service. That uses, this is important, UDP port 53. Okay. So here we have a typical DNS lookup. So here we've got a client. He's attempting to access Microsoft.com. And so he is part of a domain. We're not going to assume what the domain is, but this local DNS server, we're going to just pretend this is on his same local area network. These guys are on the same LAN. It doesn't say that, and it doesn't have to be that way. But for this instance, we're going to pretend these are on the same local area network. So this DNS client queries from Microsoft.com. The local server says, I don't have that in a cache because I haven't been to that site before or not recently enough to have saved it. So I'm going to query one of my root hints. And so it queries a root server. The root server is going to send a response that says, I don't know it, but try one of these top level domain servers. So it's going to go to the .com top level domain server. Okay. So now it's going to query the local server, not your computer itself, but the local server is going to say, hey, I need Microsoft.com. So it's going to send a query from Microsoft.com to a top level domain controller or domain server. This is a .com TLD server, top level domain. Okay. And then that's going to say, okay, I know where that's at. Microsoft.com is over on this DNS server. Try this DNS server. So that's what it responds back. So now your local DNS server says, okay, great. And it queries the Microsoft.com DNS server who says, okay, the IP address of the website that you're looking for is 207.46.119.190. And it sends that back. And finally, the local DNS server sends that as a response to your DNS client. So I know that's a mouthful, but at the end of the day, it's all just each of these servers pointing you closer and closer. It's essentially you're getting hints, and that's why they call it root hints, is because you're getting hints as to where to find it. So it's almost like a game of cat and mouse going on, that each one is pointing, I guess not cat and mouse, that's not a very good description, but it's a game that's going on where each one is saying, oh, no, I don't have it, but try this guy. And he says, no, I don't have it, try this guy. Eventually somebody's got it. Wherever Microsoft.com has their DNS entry stored, whether they do that with their own servers or whether they do that by paying somebody to host their DNS information, then they resolve that information back in an IP address, right, with an IP address. So that lookup is looking for an IP address. I need the IP address of Microsoft.com. And so it gets the IP address back from its local server. So the local server, or the DNS server that you're connected to, is the one that's querying down through the DNS hierarchy. Okay, so it is a hierarchy at the end of the day. Okay, so that's DNS. This was a pretty short one, and in the next one we will look at transport layer protocols.